Hey everyone, welcome. We're now on to chapter 8, and you might have guessed we're going to be discussing risk and return. So specifically in this video, we'll look at 4 objectives. First is actually calculating our profits and figuring out a way to annualize that rate of return. We'll also introduce the idea of risk and how it's related to uncertainty. We'll do some history lessons and compare 4 investment opportunities. And finally, we can't not talk about statistics, so we will calculate some standard deviations and variances, and again, see how that relates to risk. So, return. What is return? What does it actually mean? Well, really, it's an evaluation of the performance of that investment. Okay, so this is what we mean. And think of return as your rate, but you can also think of it in terms of performance. Now, what is the relationship between return and risk? Well, we'll take some time to think about that, and hopefully by the end of this chapter, we'll have a better understanding. But there's certainly a connection here in terms of expectation. So when we talk about return, we can look at it in 2 ways. First, we can actually look at it in regards to an actual dollar amount. So did we actually make a profit, or did we incur a loss? How do we calculate that? Well, it's basically our income minus the cost of that investment. This is what we mean by ending value plus distribution. So ending value would be, perhaps imagine if you had a stock. Well, when you sold that stock, that future value, that would be your ending value, the price of that stock in which you sold it. And the distributions, if perhaps that stock had any dividends, that would be part of your income as well. So we would add that as well. Then we subtract the cost of that stock. So that's an example of what we mean by our ending value plus distribution minus original cost. So that's the dollar amount, but also we can look at it from a percent point of view. And this is what we mean by the rate of return. Okay, so again, we take that profit or loss and we divide that by original cost. And that gives us an actual rate of return. Now, think of rate of return also in regards to a holding period rate, because we're referring to how long we're actually holding that investment. So that we can calculate holding period rate. Again, same logic applies, and you can see it factored in a different type of ways, but all mathematically. In all cases, we'll get what's called a holding period rate. So let's look at an example here. In this example, we're going to look at 2 investors, and we're going to calculate the holding period rate and, of course, the dollar amount of profit or loss. So first we have Joe, and Joe has bought in some coins. Okay, so the price of $1,000. And 4 months later, we sell it for $1,200, or Joe does. Okay, then we also have Jane. Now she's into stocks. She bought 100 shares of a stock for $10, and she held it on this stock for 2 years. And now she's going to sell it for $12 a share. But we also have to remember that she actually is going to receive dividends for these shares. So we have some distributions we have to add into our calculations. So that's what we're going to do. We're going to calculate first the dollar profit and then also the percent return, or the holding period rate. So let's do that. First, we have Joe's profit. Well, remember, what was the price he sold those coins for minus the original cost? He sold them for $1,200. So we're going to subtract the original cost, which is $1,000. So his profit was $200. What is the holding period rate? Well, we take that profit divided by the original cost, and that's going to give us a rate of 20%. And then we have Jane. Jane, she bought her stock, so we'd have to consider that a distribution in terms of dividends, okay? But the same idea. She bought that stock, or she sold that stock, for $12 a share. She bought 100 of these shares, and she also received the dividends of half $1 or 50 cents a dollar per share. And if you remember, she bought the stock for $10 a share. So that's what these numbers here show. Again, we have 12 times 100 for the price that she sold. Then we have our dividends here, and finally the original cost. So when we do the math, we get a profit of $250. So what is Jane's HPR? Well, we take our profit divided by cost, and we get 25%. So the question may be, which investment is better? Well, can we determine this based off of HPR? Remember, holding period rate does not take into consideration the length of the investment. And this is why it's very challenging to make a fair comparison. This is why also we need to convert that holding period rate to an annual return. So then we're standardizing that return over a certain period, okay, which is our annual return. So just that we need to standardize these holding periods because they're very, they're not standard, right? They're varying. So in order to do that, well, we need to convert into an effective annual rate of return. So in essence, we're trying to find that rate of return, but on an annual basis. We're annualizing that rate of return. So we take that holding period rate and we basically turn it into an annual rate that we can then compare certain investments. In this case, Jane versus Joe. So really that N is going to help us annualize it. And that N really represents the proportion of a year, right? So remember, what's 4 months in terms of a year? What's 2 years in terms of a year? That's going to help us understand that. So let's go back to our example. If you recall, we had Joe's HPR was 20%. It was over 4 months, while Jane's HPR was 25% over 2 years. Okay, and we're really going to answer this question. Can we say that Jane's investment was better? Let's take a look. Once we annualize it, then we can make that assessment. But right now we can't. Okay. So in other words, we have to calculate the ERA and then make the comparison. So again, what was that proportion in terms of those 4 months to a year? Well, we take the holding period, and again, we're trying to calculate N. So we take the 4 divided by 12, the 4 months. In other words, basically, Joe held on to that investment for about a third of a year, right? Makes sense. And knowing that, then we can actually calculate Joe's ERA. Okay, so we plug it into our formula, and you can see that we actually had a pretty good rate of 72%. Because remember, it was a very short period of time, and it was still a pretty good increase. Okay, so this is where you can actually see the differences and how the actual time makes a huge factor in evaluating investment performance. Now let's look at Jane. So Jane's holding period was much longer if you look at it, 2 years versus 4 months. I think I'm leading the witness here, but anyway, let's get to the math. So if we take 2 years. And of course, again, how do we calculate our N? Well, it's a little bit easier because we know that 2 years in terms of the amount of years is 2 years, right? It's not a third of a year. It's the number of years is 2 years. So it's kind of standardized for us already. So we plug in the N equaling 2 years, plug it into our formula, and you can see that Jane's ERA is much lower, 11.8%. So now we actually have a fair comparison, and we can actually conclude that, Joe's investment is much better. Okay, so it outperformed Jane's investment. Again, it was a shorter period of time. It was quite a good increase. So you can see that really makes a difference in terms of calculating the effective annual rate. However, now maybe something you might have recognized as well is that, yes, mathematically this makes sense, okay? But we also have to think about this. So Joe made that investment. It was over 4 months. He made a good return. But does that mean that investment is going to last for the whole year at that same rate of return? Okay, so that's basically what this is implying, is saying that if he kept that investment going for a whole year or further, he would get a rate of 72%. That seems a little unrealistic, right? So sometimes over a short period of time, You can have a high period rate, which is fine, but it's unrealistic that that is going to last for a longer period. Okay, let's take a look at what we mean by that. So again, if we look at an example here, we buy a stock for $2, right? And a week later it's $2.50, which, that can happen. Okay, but imagine, again, if it does happen, is that going to happen for the entire, rest of the year? Probably not. But anyway, mathematically, what we're going to calculate is we're going to figure out N. So again, it was only 2 weeks, right? 1 week. So basically 1 out of 52 weeks is basically 0.0192 of a year, right? So a very short period of time, we get a very small N, okay? So when we actually plug it into our formula, so we know our profit was 50 cents, right? So in other words, it's a pretty big increase in a short period of time. But what happens with our holding period or rate? So 25%, that's fine. But when we use an N, something so small like that, such a short holding period, what happens mathematically is we get a ridiculously high AR. Okay. So again, what's happening here? Why is this unlikely? Why does it look ridiculous? Well, because it's assuming mathematically what you're saying is that every week I'm going to have a 25% increase on my investment, which mathematically, yes, that's true. And this is what would happen as an annualized return over 10 million %, which is true. If you started at $2 and you want 50 cents every week, in terms of percentage, 25% increase, you would get a really high return. But that's a little unlikely. Okay, so this is why we have to start considering the frequency of our investments. And when we talk about frequency, this is when we start talking about risk and certainty versus uncertainty. Okay, so the reality is we can't really dictate the future. We can't really predict the future. Okay, and this is why there is some risk associated with investments. Okay, and basically what we mean by risk is the potential to lose or some sort of loss, right? So, the potential to lose what we've already invested, okay? If we want to be more specific, we can measure risk, and this is based off of the amount of uncertainty that's associated with that investment outcome, okay? This is what we mean by risk. So if there's more uncertainty, then we have more risk associated, okay? If there's less uncertainty, then we have, less risk. And this measurement is what's helping us make informed decisions, okay? Certain investors have higher levels of or tolerance for risk. Certain investors do not, okay? So it doesn't necessarily mean that, there's always the right investment choice, but we have to understand the risk associated with each choice. So we're going to start looking at 4 investment options, and here we can see some visuals. Okay, so our histogram here. So in this case, we have 4 options here. We have A represents our treasury bills. Okay, we can invest in a treasury bill. Remember, this is a very short-term investment, and we're investing in pretty much government agencies. Okay, then we can look at long-term government bonds. So these are a little bit longer. Long-term government bonds here on B. Then when we go to C, we're actually looking at large company stocks. And finally, D is we're considering small company stocks. Now, what does this graph represent? Well, here, if we look at the y-axis, we have the frequency. Okay, so how often? Remember, think about it in terms of risk. What is the amount of potential outcomes? So how often that's happening, the frequency in the result. And we're on the x-axis, we're looking at the rates of return. Okay, so frequency and rates of return is what this is comparing. So what do we start to see? And we'll look at this in a few different ways, but it's good to start here. And it's good to start with compare maybe A, which is our treasury bills, and D. Okay, these are basically our 2 extreme examples, and we'll see why. So first is the question you might want to ask is which company had the highest rates of return, okay, on average, okay? Now, one thing to look at in regards to this is you're going to look, basically the highest rates of return are going to be all the way on the x-axis here. So if we look at D, we can actually see, particularly from 20 to 30% and above, in terms of the frequency, it looks like it's a lot more frequent in terms of our small company stocks. So that has the highest rate of return. And actually, if you reference this to the textbook, you can actually, you'll see that the small company stocks earn the highest average rating. Okay, so they earned a rating of about 17%. Okay. However, what about the variability? Okay, so one thing you might also notice is that, and we'll look at this as we go through the chapter here, but you'll also notice just by looking at this chart is that they had the highest variability. There was also a lot more, a wider range of potential outcomes, okay? And particularly if you compare D to A, you'll notice that A actually had zero frequency in which there was a negative outcome in return, okay? So in other words, A looks like it's the safest investment choice because in no case did you actually lose your return on your investment, okay? Where if you look at D again, look at D in terms of, even though it had overall the highest average rating or return, it also had, in terms of frequency, it also had the most frequent negative returns, both less than 10% and even 0 to 6% as well, tied with C. So you can see this is what we mean by variability. This is what we mean by more uncertainty, okay? And we start to sort of understand the relationship between risk and return, okay? And again, the question might be, what is a better investment? Well, that depends on what risk you're willing to take and so forth. But that's important just to see that visually. Now let's take a look at it in terms of statistics when we actually understand how do we calculate or how do we measure that uncertainty in regards to statistics. So we need to first identify standard deviation and variance and how that measures risk, okay? So what do we mean by variance? Well, we mean basically, and we're going to use variance and standard deviation similar in regards to it's pretty much the widening of uncertainty. Okay, so the greater the variance, the greater the standard variation, the more uncertainty. Okay, so that's what we're measuring. So how does this help us? Well, again, just like we came up with some of that data in the histogram, it helps us understand how often we can expect a certain return in a certain category. And we'll look at that in just one moment. Okay. And as we sort of mentioned, if you have a larger variance, that means there's more variability. Therefore, there's more risk associated. Okay. And of course, we have some formulas here. I'm not going to worry too much about the formulas, but we will look at an example. So here, let's take a look at figuring out the variance of a large company's stock. Okay, so again, we're going to use our historical figures, and ultimately we're going to calculate the standard deviation of that stock, and that's going to help us understand the level of uncertainty. So what we're going to look at is we're going to look at the annual returns of large company stocks, okay, basically for a certain time period, and we're going to calculate the variance and standard deviation. So what do we see here? We see our returns. One thing you don't have here is the mean, but imagine you did have the mean. Basically, these returns are a comparison to the variance or the difference between the mean and the actual return. Okay. Again, I'm not going to spend too much time on the calculations. We can look at that in other videos. But basically, what we're trying to figure out is our standard deviation. And what we ultimately do is we take the really the difference or the variance from between the mean and the return. Okay, we add them all up, we get the sum. Then based off of that sum, we can figure out the variance and the standard deviation. So let's look at an example here. Again, we've gotten the variance, and this is how we calculate our standard deviation. Okay, so that's where we got our 14.2%. But what does that look like in terms of an actual distribution curve? Well, let's apply the same sort of idea here, and we'll look at it. What happens when we have the mean and the standard deviation? How can we actually see that represented on a normal distribution? So again, this hopefully is a bit of a review for you. By now you should have an idea of what it looks like a normal distribution curve. Okay, so just a little review. Remember, we start at the mean, which is 0, and then we have our standard deviation, right? One standard deviation plus or minus the mean. Two standard deviations is plus or minus the mean. And then finally, three standard deviations is plus or minus from the mean. So in this one standard deviation, you're looking at about a 68% probability. Two standard deviations here is a 95%. And then finally, we have a 99% across three standard deviations. Okay. So again, really think of probability connected with our uncertainty, depending on where that lies. So let's take a look at an example, because there's a lot of jargon thrown here. So first, if we know the average return, or the mean was 10% of a stock, okay, and we have a standard deviation of 12%, what does that look like on our curve? Well, again, we start here at our mean, and we have a 10% return. Okay, so the first deviation, in other words, the 68% probability that our stock is going to be from what? Well, it's going to be minus the 12% standard deviation, which is -2, all the way to the plus 12 from the mean, which is the first standard deviation, up to 22. Okay, so in other words, we have a 68% probability that that return is going to fall between -2 and 22. Okay, and again, how did we get that -2? Well, we start from the mean, and we subtract 12, which is our standard deviation. That's one standard deviation. And then we can also go forward. So if we take that 12% standard deviation, add 10 to the mean, we get 22%. Okay, so that's what we mean by understanding the probability of our return in terms of one standard deviation, and we have a 12% return, and our mean is 10%. Now, what happens on the second standard deviation? Okay, so what happens basically in the 95%? Okay, so we have a greater probability. We want to figure out what our returns are in regards to the second deviation. Well, we basically add on another 12 negative and another 12 positive. And now you can see that there's a 95% that our stock is going to, our return on our stock is going to be from -14% to 34%. So you can see that, there is the risk associated with losing our money on our investment, but there's also a good chance that we might have a positive investment, a greater or a high percentage increase, which is 34%. But again, how do we calculate that? Okay, so we know now 95% will be between -14 and 34%. How do we get to -14? And there's really two ways to look at it now if you want, but we always think about what is the standard deviation. So in this case, the -2 is what we had from the first standard deviation. If we add another standard deviation, then we're really just subtracting -2 minus 12 again to get to 14. And again, if we look at it from adding from the mean, the plus from the mean, well, if we were at 22% from the one standard deviation, we're adding another standard deviation to get to 34. If you want to look at it from the actual mean, well, then basically you start at 10, and then we're going to add two standard deviations. So two standard deviations at 12% each is going to give us 24% going negative, and then two standard deviations going forward, again, we're going to be adding 24% to the 10% mean, which is 34. Yeah, but you knew all this. This is just review. Just take a look at some wonderful colors. And finally, we have the third deviation. Okay, so now we're looking at basically 99 point something percent. Okay, what's our probability of a return? Okay, well, again, we're just adding another deviation. So now we can add another 12 from the 14 I guess we should think of it as subtracting 12 from the 14 when we're looking at negatively. Okay, so that's why we have a negative 26. And also we have a 46% when we add another 12 positively. Okay, so again, how do we get that negative 26? Well, if we were at negative 14, we're going to subtract another 12. Or if we're at 34, we're going to add another 12. Okay, or you can look at it as 3 standard deviations from the mean. So we take 3 times 12, right? So 3 times 12 brings us all to negative 26. If we look at it the other way, we start from the mean at 10% and we add 36, and that gives us 46. Okay, so just a little reminder of how it relates, how we can apply statistics to investments and understand how that actually relates in terms of our probabilities. So when we compare those 4 options here, okay, and hopefully now we're starting to see that relationship between risk and return, okay. And when we actually compile the averages, again, if we look at the average return of the 3-month Treasury bill, we can see that the return is quite low, okay, but it also has the lowest variance and the lowest standard deviation. And remember, there are no negative returns when you're making this investment. They're all positive. So even though this has the lowest risk, it also has the lowest return. Okay, so we have no risk of losing our money, but we also have a lower return. And as we move through the investment options, we can see that the return increases, but what happens to the standard deviation? Well, that also increases. So again, as we see the standard deviation, that really implies the level, or the greater the standard deviation also recognizes the greater the risk associated. Okay, but again, higher risk means a higher possibility, a higher, there is an opportunity for more positive returns, okay, or higher returns. I shouldn't say positive, okay, with the 17%. So ultimately, what is that really telling us? Well, we're starting to understand, okay, when we actually look at risk versus return, we can now start to see that typically speaking, companies, like small company stocks, okay, a little bit more unknown, they have a higher reward, but they also have higher risk. Okay, whereas by now we shouldn't be surprised that those short-term government investments, they're pretty stable. We talked about the idea of default premiums and things like that. This is really the lowest risk investment you can make. Okay, risk-free kind of investments. They still have a little bit of risk in terms of inflation and things like that, but there's no default risk. There's no maturity risk associated. So ultimately, this is why we see them having very, very little risk, but they also have very, very little return. So now we can see that, and this is all historical, but we can also see that riskier investments, they earned higher returns, and vice versa. Okay. So this is why we kind of start to expect that the riskier the investment, the higher return. Okay, and again, so there's no wrong investment. It's just a matter of what we expect in terms of what we can tolerate as well, what we're willing to tolerate in terms of our investment. So I hope you start to understand now the difference, or the relationship between risk and return. Okay, now we've only discussed sort of the historical data to calculate risk and return. But join me next time as we move from the past to the future. Thanks for watching, and happy financing.